Do you remember how to divide fractions? For example, suppose you had 2/3 divided by 5/7. How do we do that? Well, actually, most students, I think, tend to remember this. They say, well, you flip it and multiply. All right. Well, you invert and multiply, but what are we inverting? We always invert the second fraction. So it becomes 2/3 times 7/5. Okay, if you can believe that. All right. And then at this point, we would just multiply across and would get 14/15. I want to justify that inverting and multiplying process, but it's wonderful because it allows us to turn any division into a multiplication. And we could go the other way, turn any multiplication into a division if we wanted to. But it's very useful because we've learned how to multiply, and it's it's easier to deal with than division, as it turns out. So let me justify this algebraically, in case you've always wondered, why do you invert and multiply? All right, so I'm showing you all this great stuff that you probably should have been shown earlier, but may not have seen. And so, because I know, you come up to the public schools and you get pontificated at. Here are the rules. And but why are these rules? Okay. Well, suppose I had, we'll just do this algebraically. A over B divided by C over D. Okay. I'm going to think of it this way. I'm taking this fraction and dividing it by that fraction. In other words, I have A over B divided by the fraction C over D. So it's a different way of writing this division. And at this point, I'm going to multiply by 1. Okay? Except it's going to be what we call a well-chosen one. Up here, I'm going to write BD over 1, and then divide by BD over 1. Now, will you agree that everything in red here equals to 1? Because this and this are identical, a number divided by itself is 1. And if I multiply by 1, then nothing changes, does it? Okay. We're going to use this technique in a later section to simplify complex fractions with algebra. So actually, we'll see this type of technique come up again. But for now, if I look at it, I multiply across, don't I? Because I'm multiplying fractions. So when I multiply across, I'm multiplying this fraction times this fraction, and those b's will cross cancel. Down here, I'm multiplying these fractions together. The d's will cancel. And what I'm left with is AD divided by CB. I'm going to write it BC to put it in alphabetical order. But A times D over 1, C times B over 1, AD over BC. Now, isn't that the same as inverting and multiplying? So if I took this fraction and, oops, let me make that A, and inverted the second fraction, made it D over C, and multiplied, then I will get AD over BC, wouldn't I? So there you go. We just proved that for all fractions, when you divide fractions, you can invert and multiply. And because this is a generic type of proof, in other words, you can substitute any quantities you want here, and the same principle holds, that you divide by inverting and multiplying. So there you go. Now you know the rest of the story. Okay, now I'm going to erase the board and put up one of the problems from this section. Here's our division. Simplify or divide. X squared plus 5x plus 6 divided by x minus 4. And then this is all divided by the fraction x plus 2 over x squared minus 16. So let's go ahead and invert and multiply here. So I'm going to recopy the left. You always invert and multiply the right fraction, right side fraction. It would really screw it up if you inverted this one and multiplied. Okay, so now it's a multiplication, and it's pretty standard from here. Let's do some factoring. I'm going to go kind of fast here. This will be x plus 2, x plus 3 over x minus 4 times, and this factors as x minus 4, x plus 4, and I have my x plus 2 here. And nice things happen. The x minus 4's cross cancel, and so do the x plus 2's. So we're left with x plus 3 times x plus 4. Alright, so as far as I'm concerned, we're done. Now it's tempting, or you might think, well, aren't I supposed to multiply that out? Okay, and it's not wrong to multiply this out, but it's also not productive. Because it turns out to do a lot of processes in algebra, when you have polynomials, it's advantageous to keep it in factored form when you can. For example, if this fraction was, if this problem was equal to a number over here, well, if it was equal to 0, then it would be easy to solve. It's already factored. And so, there may be a reason to keep it factored in a more complicated, more advanced problem. So I would say keep your answer factored. It's actually potentially more useful in this form. And the nice news is that it's less work. You don't have to multiply this out. So there we go. There's a division problem for you. I have one more to show you on the next topic.